All right, here we go, kids. We have calculus assignment 1D. This is all about exponents, understanding exponents. So let me go to a different screen here before we actually get to the lesson. So basic idea about exponents. First, understanding what an exponent does and things like that. So if I have a number, I'm just going to random number 5. 5. If I have 5 to the 2, then that's pretty easy. It's easy to understand. It's 5 times 5, and it's 25, et cetera, et cetera. But what happens when I do weird things with this exponent? So what this would be, what happens if I make it negative? Negative. It doesn't make it a negative 25 or anything. All a negative does is it moves it. If it's a bottom number, it becomes a top. If it's a top number, it becomes a bottom. And so this would be 1 over 25 in this situation. What if it's a fraction? If it's a fraction, the numerator of the fraction is still the exponent. So this is has 5 to the power of 1. So it's still the exponent of that number. The denominator is the type of root that it is. So this is a square root of 5, okay? Square root of 5 in this situation. That's what a fraction is. So and you can put them together. What is 5 to the negative 1/2 sort of concept? So it's a negative, so this top number becomes a bottom. Okay, so it becomes 5 to the 1/2, like that. So the 1 is still an exponent, and the 2 is the type of root, and so this would be a 1 over root 5, like such. All right, and so that's kind of just basic understanding of the exponent themselves. Next thing that you kind of have to understand is, what do you do with exponential arithmetic? Like, what happens when things with exponents are added to each other and subtracted and things like that? And the concept is this. They mostly have to have common bases, aka the bottom number has to be the same. So if I have two numbers and they are adding, okay, then nothing happens. They are what they are, right? What happens if they are multiplying? All right. And what happens when you multiply is you add. Okay, you add. Because you got to think about this. This is 5 times 5. This is 5 times 5 times 5. So what happens when you have 5 times 5 times 5 times 5 times 5? Well, then you have, obviously, 5 to the 5th, which is exactly what you get when you add the exponents. So in a multiplication, you add. What happens when you have an exponent to an exponent? Okay, an exponent to an exponent. Well, in that situation, when you have an exponent to an exponent like that, you multiply them. Because again, this is the same thing as saying 5 times 5. Well, what happens when you have 5 times 5 times 5 times 5 times 5 times 5? You have 5 to the 6th. All right, so 2 times 3 is 6. So you multiply. So the way that I remember that is pow, pow, like a power to a power, pow, pow, multiply now. Pow, pow, multiply now. And then similar things happen when you have like the negative versions of these, like 5 squared minus 5 to the 3rd. Nothing happens. is what it is. When you divide, when you have 5 squared divided by 5 to the third, all right, you subtract. So 5 squared divided by 5 to the third would be 5 to the negative 1, aka 1 over 5. Okay. The way that I kind of do this is I take a look at the powers. Which side is bigger? The bottom. So that's where the base goes. By how many? How many is the bottom bigger by? Oh, it's bigger by 1. So it'd be 5 to the 1 on bottom. And then last but not least is roots. Like what happens when you have the third root of 5. I'm going to change this one up, 5 to the 9th or something like that. And that is a division. Because again, think about what this is. It's 5 to the 9th, and the other way of writing it is as a fraction, right? Is like that. Okay, so let's kind of go back to our assignment and see what we have to do. All right, so evaluate the expression. All right, so we have numbers to various exponents. All right, so what this is the square root of 25 to the third. All right, so the easiest way to do this one is to try to take the square root first. So the square root of 25 is 5. 5 to the third is 1 comma. That's the simplest way of doing it. 81 to the 1/2 is the same thing as the square root of 81. 3 to the negative 2 is the same thing as 1 over 3 to the 2. 27 to the negative 1/3 is the same thing as saying third root of 27 as a denominator. (64 to the 1/3 is the third root of 64. 5 to the negative 4. I'll probably need a little calculator help on this one. 5 to the 4 on bottom. 5 to the 4 is something big. 600 something big. 625. One eighth to the 1/3 is the third root of 1/8. When you have something applying to a fraction, it applies to both the numerator and the denominator. So the third root of 1 is 1. Third root of 8 is 2. Same with exponents. So 1 to the third is 1. 4 to the third is 64. Okay. This bottom problem, number 5, is all about what I was kind of explaining about adding, subtracting, multiplying. So here we have a multiplication. E to the 3 times e to the 4. Multiplication implies addition. Part B, we have a power to a power, a 3 to the 4th. Pow, pow, multiply now. Same with letter C, power to a power, pow, pow, multiply now. Okay. Or I'm not sure exactly how they want it written. It's one minor and the other. Sometimes they don't like negative exponents. So it'd be a negative, excuse me, as you were, it'd be e to the 6th on bottom. And then anything to the 0th power is equal to 1. Anything to the 0th power is equal to 1. Last but not least, solve for the x. Most of these things you can get a common base. So this is a 3 to the x. This is a 3 to the 4th power, right? Yeah. So when you have a common base, you can eliminate the base itself. And you can solve it without getting into logs. This next one is 6x minus 2. This is 6 squared. Obviously, So now the common base goes away. That means x minus 2 is equal to 2, thus x is equal to 4. This is a 2 to the negative x. This is a, actually, hold on. Hold up. 1 to, okay. What is a 1/2 to create a 32? 32, it's a 2 to the 4th, right? There you go. So now it's a 2 to the 4th. So 2 to the 5th. Yeah, sorry. 2 to the 5th creates a 32. So I need to get a power of 5 on that 2 somehow, and then, so I need to make it a numerator. So now this is a 2 to the 5th. That's it. This is written as 2 to the 5th. Okay, similar over here. This is a 3 to the 3rd, a 3 to the 3rd. So now that's a 3 to the 3rd. Okay, if these two things are going to be equal to each other, a 4 to the 3rd is going to be equal to a 4 to the 3rd, obviously. That would mean that x plus 2 has to be equal to 4. A 4 to the 3rd is equal to a 4 to the 3rd. X to the 3/4, I'm going to rewrite this as the 4th root of x to the 3rd is equal to 8. So this is going to get a little nasty. To get rid of the 4th root, I take it to the 4th power. And then to get rid of the 3rd, I take the 3rd root. So this is going to be 8 to the 4/3. I don't think that's anything good. I'm just going to leave it as that. So I don't believe anything to write home about. Oh, snap, 16. E to the x is equal to 5. Here is where another little mini lesson. E to the 2 or something like that. To get rid of an E, say it's in an equation or something like that, what you do to get rid of an E is you take the natural log, which is the ln. So if I take the ln of this eliminates the E, which leaves the exponent comes down to be a base number. And so 2 is equal to the ln. And I know this is not correct, this is not true, but this is what we would do in this situation. Yeah, so that's what you would do. And vice versa. To get rid of an ln, you take it to the power of e. All right, so if I have the ln of x, I could take e. And so thus x is equal to e squared, right? Just like how the original equation would look. So natural logs and e's undo each other. Okay, back to this. So to get rid of this e, I have to take the ln of both sides. So the ln, so x is equal to the ln of 5. All right, so here we have a common base, so the bases drop, and so that just leaves negative 2x is equal to 5, x is equal to negative 5 halves. I think that's That's it for the assignment. Hooray!